3 and also Quest 3 and also the market survey. So we also need to identify the patented certification and record the exclusivity period expiry if available. We also have to search for journal, books or article related to the product you want to develop. For example, characteristic of the active pharmaceutical ingredient, the excipient used, the manufacturing process, the challenges you can see. So this is an example of the website. This is the US FDA, the Orange Book. This one, the Quest 3 MPRA website. And this one is the EMC, Electronic Medicine Compendium, that I said before. So after comprehensive literature review, so we need to characterize the reference listed drug or innovator, which is used as a reference for our generic product development. So we need to determine the product name, the API, the strength dosage form, manufacturer, manufacturing expiry date, and also the physical properties, because this information will be guide you to develop the generic product. So basically, we can identify, determine the information, everything by referring to the package insert and also the packaging box of the product. So next is the characterization of active pharmaceutical ingredient, which is API. The API is very important because it will give the therapeutic effect of the product. So for API, we need to determine the solubility profile. What is the pH, what is the acid dissociation constant, the partition coefficient, because it can affect the dissolution and also the drug bioavailability. Next, we have to determine the polymorphism, either it exists as amorphous or crystalline, because different polymorphic will have different solubility, and also we can impact the tablet dissolution. Next is the particle size, shape and surface area, and so the flow properties by determining the bulk density. So bulk density is measured by gently introducing a non-sample mass into a graduated cylinder and carefully leveling the powder without compacting it. We call the bulk density to determine the flow properties of the API. Because the flow properties of API can affect the content uniformity of the API in the tablet. So next, we also need to determine the chemical stability profile, either it's hygroscopic, heat sensitive. We need to determine it. Next is the natural source, because we have to request from the manufacturer for the halal certificate, halal declaration for the product registration purpose. Next is the choice of excipient. Okay, based on the technical consideration, we have to choose the excipient based on its function, and the percentage or limit used should be within the limit as per the handbook of pharmaceutical excipient and also the drug registration guidance documents, the RGD, that you can refer to. Because it is very important. If the restricted excipients such as menthol, you have to measure, you have to determine the limit when taking according to the dosage. It's very important because it relates to the safety. So next is the compatibility study between the API and excipient. It's very important to determine the compatibility between API and excipient use, because this is an important part to understand the role of the inactive ingredient or excipient in product quality. Because in some cases, if there is interaction between API and excipient, it can affect the assay of API and contribute to the presence of the undesired degradation product. After the literature review, after we got all the information, got the idea, so we'll proceed with the formulation development. So during formulation development, we have to develop several formulation trial batch. And during the trial batch, we have to optimize the formula and also the manufacturing process. For the formula, we have to optimize For example, the amount of binder you use, the amount of disintegrant you use. And also we have to optimize the manufacturing process, such as the granulation time, lubrication time, because it can affect the properties of the finished product and also behavior. So after I get the optimized formula, so we will proceed to produce a small scale batch to set down for the 6 months R&D stability study. For the R&D stability study in Malaysia, Asian region, we follow the zone 4B region, which is hot, higher humidity according to the ICH guideline. For the stability, we need to set down for 2 different conditions, which is a real time, which is 30 degrees Celsius, with the 75% relative humidity, and also accelerated condition at 40 degrees Celsius with 75% relative humidity. After get the optimized and the stable formula, will we proceed with the pilot batch manufacturing which is done at the manufacturing size. So for pilot batch size, it is correspondent to at least 1/10 of the commercial batch size. So for oral solid dosage form, basically is at least 10% or 100,000 units, which is the greater otherwise justified. So as a formulator, in the formulation, we have to support the manufacturing site by review the BMR, the batch manufacturing record, which record the excipient used, the process that we go through, and also we have to review the batch packaging record, which is to ensure a correct packaging material will be used. And also during the pilot batch manufacturing, we have to witness the process and also the monitor the process with the production team. So next, after the pilot batch manufacturing, we'll prepare the dossier for the product registration. So as a formulator, we also not even develop the product, we also need to support the product registration in terms to prepare the related documents such as the pilot batch report, the product development report, and also to provide the calculation of the restricted excipients such as menthol, saccharin, sodium according to the dosage. And also we have to review and provide the drug master file of API. This is very important during the product registration to MPRA. So next, we will go through the formulation of the tablets. Tablets are solid dosage form which contain one or more drug substance with the suitable pharmaceutical excipient. So the tablets may have a different size, shape, weight, hardness, disintegration, and dissolution behavior. So the tablets are manufactured by compressing the uniform volume of the particles, granules or powder into various size and shape according to the punches that we use. There are various types of the tablets, including which are ingested orally, a tablet used in the oral cavity, tablet administered by other route such as the vaginal tablet, and also tablet for solution such as the effervescent tablet. So usually in Pharmaniaga, we manufacture the orally ingested product, or we call it the oral solid, OSD, oral solid dosage. So next, beside of the API, so we also need to focus on the excipient. The excipient, what is the excipient? Excipient or we call as inactive ingredient, which are inert substance, which are included in the manufacturing process or contained in a finished product. There are various types of the excipient used during the tablet manufacturing, tablet formulation, according to its function, such as diluent or fillers, we call it, disintegrant, glidant, surfactant, coating agent, lubricant, and binders. So for diluent, I will briefly explain the type of excipient here. So for diluent, is used to make the required bulk of the tablet when the drug dosage itself is inadequate to produce tablets of adequate weight and size, such as lactose and also the microcrystalline cellulose. So, but for binder, it is used to add the cohesiveness to powder to provide the bonding between the granules formed. For example, starch, povidone, and next is disintegrant. So disintegrant is used in the tablet formulation to facilitate a breakup or disintegration of the tablet when placed in a aqueous environment, because it is very important process to disintegrate first the tablet and then the dissolution process and also the drug absorption and bioavailability. So this is very important. The example of disintegrant use is the cross-caramelose sodium or sodium starch glycolate. So for lubricant, it is used in the formulation to reduce the friction during tablet formulation in a dye of the punches. For example, magnesium stearate, calcium stearate, stearic acid. So for glidant, it is used to promote the flow of tablet granules or powder mixture from hopper of the tablet compression machine to the dye cavity by reducing the friction between particles. And the glidant used as example of the talcum or the colloidal silicon dioxide. And flavors is used to improve the taste, especially for the chewable tablets, and the colorant for product identification, and also for product to look more elegant product. And for sweetener, it is used to exclude or limit the use of sugar in the tablet, especially for the chewable tablet. So next is the purpose of excipient. So excipients are added into the formulation first to aid the manufacturing process of the finished product. For example, during the tablet compression, we have to prevent the sticking problem to get a proper tablet formation. Next, the excipients are added to protect and also enhance the stability of the formulation, to back up the formulation in case of the potent drug, to improve the patient acceptance, to improve the bioavailability of the active drug, and also to enhance the safety and effectiveness of the formulation during its storage and use. For example, by using the coating agent. So excipients can have a considerable impact on the formulation. Therefore, it is very important to select a suitable excipient grade. So the selection of the excipients depends on the several factors. First is physicochemical properties of the API. Either it is hygroscopic, moisture sensitive, or poorly soluble. Next is a delivered dose of the drug. Because low dose of the drug can have content uniformity problem. Meanwhile, for the high dose of the drug can have a direct physical impact of API on the tablet properties. So we also need to consider the manufacturing process requirement. Either it's involved in the direct compression or that granulation, because for certain process, they got the suitable excipient can be used. So next is desired release of characteristic. For example, for modified release of the API, we have to use the enteric coating. So next is the manufacturing process of the tablets. So tablets can be manufactured by 3 methods. For example, the direct compression, the dry granulation, and wet granulation. For dry granulation, there are 2 methods, which are including the slugging and also the roller compactor. So for direct compression, the tablets are compressed directly from the powder mixture or blending of the API of excipient. So first thing first, for the process of the tablet formation, we need to dispense the active form, the API and also the ingredients or excipient used. Dispensing means maksudnya macam menimbang dispensing, because in hospital we said that dispensing of the medication, giving the medication to the patient. So dispensing here means weighing the material or excipient. So next we'll go for the sieving process. Sieving means tapis. After you timbang, then you have to tapis to have a uniform size of the particle of the powder. So next we go for blending, and after blending all the excipients with the API, we will compress the tablet. This is very simple method for direct compression method. Next is a dry granulation. So dry granulation is to form granules without using a liquid solution due to sensitivity towards the moisture or sensitive, or the formulation have the flowability problem if manufacture the tablet using the direct compression method. So basically we go for dispensing, blending of the ingredients, and compress into big diameter or flake. Then we have to mill the tablet. Milling means the reduce the particle size. So the blending, and after blending we go for the compress into tablets. So for dry granulation, it involves two processes. So for dry granulation, it uses the compaction process in order to densify the powder to form the granules. So for two methods for roller compaction, after blending of API and also the excipients, it will pass. The blend will pass between two counter-rotating rolls to form the flake of the compact, or we call the ribbon. And then the flake will be milled, reduce the size to form the granules. And after granules, we go for the compression. Meanwhile, for the slugging method, is use a heavy-duty tablet press to compact the dry blend to form the slug or tablet, a big diameter of the tablet. Then after that, the slug, a tablet, will be milled, reduce the size to form the granules. Then proceed with the granulation. We proceed with the compression. Next is a wet granulation. So dry granulation, basically no use of the liquid, but we want to form for dry granulation, we want to form the granules without using any liquid. So for wet granulation, we want to form granules by using a granulating fluid, or we call as a binder solution. So basically it involves the mixing of a mix of dry powder particles using a granulating fluid. The first, it starts with the dispensing process, then blending of the excipient and also the API, and also we will put the granulating solution during the granulation mixing, and we will screen the wet granulation, the wet mass, and then we go for the drying process. After the drying process, we will screen the dry granules. If there is a retained dry granules, it will go for the milling process to reduce the particle size, and then we go for blending with the lubricants. Okay, actually the lubricants are added prior to the compression because we want to form a low strength bond on the surface of the granule, which help flow of the granules and prevent the granules from sticking to the face of the punches during compression. And after the blending with the lubricants, then we go for the compression. And next I will go to each process which involved in the tablet manufacturing process. Okay, first is a dispensing. The dispensing is the process of you prepare, you measure weighing and deliver the pharmaceutical raw materials. So dispensing is the first step in the manufacturing process. It is performed in reverse laminar flow powder dispensing booth, or we call as a powder containment booth, in order to protect the operator from the raw materials, from the fluffy materials, everything used for the manufacturing of tablets. So this is this example of dispensing booth. Okay, after dispensing, for dispensing, we need to first label the name and amount of raw material to be dispensed properly and correctly in order to avoid any dispensing error, because all materials look same, look white in color. So in order to prevent the error during dispensing, we have to need to label properly and also label the name and the amount also. Okay, first we have to weigh the empty plastic bag as steel rack, and then we weigh the raw material as required as stated in the dispensing sheet. And after weighing the raw material, we have to seal the plastic bag in order to protect the excipient or inactive ingredient from contamination. So after sieving process, after dispensing process, we'll go for the sieving process. Okay, actually sieving or is known as a screening or sifting. It is used to separate fine particles from bigger particles by using a mesh or sieve with different size. So simple word, kita panggil dia tapis. Penapis lah. So the sieving process is very important to have uniform particle size distribution for granulation and also subsequent tablet pressing. So sieving process is really important because the mixing or blending of several of the ingredient is easier and more uniform if ingredient have the uniform size. There are various type of the mesh number, start with 10 up to 100 and 200 lah. So basically the mesh number, this is the mesh. So the mesh got the number. So the higher the mesh number, the smaller the aperture size per square inch. So for this one, roughly is a mesh number 30. This one a mesh number 60. So mesh number 30 got the bigger size of the size, the aperture size, but for the 60 have the smaller size. So the use of the mesh number, it depends on the particle size distribution of the excipient or raw materials. Everyone okay?
Yes.
Okay, sorry. So after sieving process, we'll go for the blending process. So blending performed at stage of pre-granulation or post-granulation stage of the tablet manufacturing. The blending is purposed to obtain a uniform and homogeneous powder mixing between the API and the excipient. It is very important. So we need to identify and determine the optimum mixing time, because prolonged mixing time can have undesired effect of the product. And also, so the optimal of mixing time and the mixing speed are crucial to be evaluated. So there are various type of blender, such as the V blender. This is the V blender. This is double cone blender, and this is a cube blender. So basically, there are different size of the blender according to your batch size of your trial of your volume of the powder. So after blending, okay, so granulation. So granulation, the purpose of the granulation process is to prevent the segregation of the constituent of the powder mix. So thus provide the homogeneity of the drug distribution in a blend. But granulation is the process where the small particle are gathered together into layers and the permanent aggregates to render them into free-flowing states. So granulation is to form the granules of the powder for easy process of making the tablet, because some product, if fine particles, we cannot compress the tablet. So we need to form the granulation for proper compression of the tablet. So this is type of the granulator we call as a higher shear mix. And the higher shear mix, we got a different bowl size. This is a bowl. So the high shear mix, it contains the impeller, the blade, the three blades here, is used to mix the dry powder and to distribute the granulating solution when add the solution into the dry powder. And after proper mixing, so this is a chopper. The chopper is to break up the wet mass into the small pieces and granules. So after the granulation, after the wet granulation, we have to dry the powder. So drying is a process of evaporating the liquid contained within the aggregates produced by the wet granulation process to a predetermined moisture content. So it is very important to keep the moisture content low enough to prevent the product deterioration and also ensure the free-flowing properties. So for certain product, generally the moisture content we have to set less than 2. The limit of the moisture content 2 to 3% we need to maintain for proper tablet compression. So for drying method, we use two different methods, which is a tray dryer. It's an oven. It is a old method of a drying, which is direct contact with the heating medium. And next is a fluidized bed dryer, we call as FBD. This is the current that we use to dry the granules. It is in direct contact of the powder within the heating medium. So next is a milling process or size reduction, we call it. It's a process to reduce the large particle into the small or coarse particle or fine particles before we go for the compression. So the dried granules, after the granulation and then drying, the dried granules will be screened through the appropriate mesh screen. If there is retain of the dried granules, it will proceed for the milling process for homogeneous particle size or granule size in order to have a proper tablet formation. So milling process is very important in order to increase the surface area of the granules, the particles, which enhance the dissolution and also the product bioavailability when taken by the patient. And next, the milling process also are important to improve the content uniformity of the tablet. So next is the compression method. After the drying, after granulation, dispensing, blending, granulation, drying, blending, and also we go for the compression. Compression is involved the process of compression, or the pressing of the granules or powder into the certain shape, or size of the punches. According to the punches, we want to have the score line, unscore, we want to have the symbol, the code number, everything using the tablet press, or we call the punches. I will show the punches after this. So basically, the compression is done by single punch machine. This is a single punch machine where you fill the powder through the hopper and then you compress it. Or it can be the compression will be done by the multi-station machine, or we call it as a rotary press. Okay, there are multiple station of the punches are set for this machine. So for the tablet compression, during compression, okay, we first we go for the filling process. The filling process, it involves the transfer of the granules of powder to the compression machine. Compression machine punch die cavity, which consists of the upper punch, die, and lower punch. Okay, this is the upper punch. This is a punches, and this is a die cavity, in which the granules of powder will be transferred to this die cavity. Okay, so this is a lower punch. Upper punch, at the between that is a die cavity, and the below is a lower punch, we call that. So the position of lower punch within the die will determine the volume of the granules. That means the volume, we call it as a tablet, the weight of the tablet, what we want. So we can adjust the position between the lower punch and the die cavity according to the set on the compression tablet machine. So after filling the granules into the die, so we will adjust the weight. So it means remove the excess granules of powder from the compression machine, which enables the exact weight or volume to be compressed into the tablet. So after filling and weight adjustment, so we will go for the compression stage, which bring up the upper punches and lower punches under pressure within the die to form the tablet. So basically, each tablet is made by pressing or compressing the granules of powder inside the die. It's just like this. You bring up the upper punches and the lower punches within the die cavity between the two punches. So after pressing and compressing, the tablet will form. Okay, after tablet will form, the tablet will be injected from the station. So the tablet, you will get the tablet. So basically, the process involves the filling process, the weight adjustment, the compression and injection of the tablet from the tablet press station. So during tablet compression, it is very important to evaluate the tablet, the physical properties of the tablet. For example, the appearance, such as the size, shape, how the color distribution, and the presence of the taste of everything. So this is a vernier caliper that we use to determine the size, the thickness, the diameter. It is very important. And also, beside the appearance, we need to determine the tablet weight. Tablet weight is very important because it helps to ensure that the tablet contains the proper amount of the drug. So uniformity of the tablet weight is very important to ensure the even distribution of the ingredient, because the API, we need to have the proper amount to have the desired therapeutic effect. So next is the hardness. Tablet hardness is very important. So we measure the tablet hardness, or we call the tablet strength. To measure the tablet crushing strength by using hardness tester. This is the hardness tester. Actually, the tablet require a certain amount of strength or hardness to withstand the mechanical shock of handling during the coating, packaging, and shipping. So by using for this hardness tester, we need to put key in the diameter of the hardness, and we put the tablet here and we test the hardness. So the hardness, usually the unit is in Newton. So after determine the hardness, we'll also determine the friability. The friability is determine the durability of the tablet by using friability tester. Okay, this is a friability tester. So how we do? We weigh the amount of the tablets. For example, 10 tablets. Okay, first we weigh the tablets. Then we remove the dust of the tablet. Remove the dust of the tablet. Then we put the tablet on this position. Then we'll set for 100 rotation, and the tablet will roll and fall within the rotating apparatus. And finally, after 100 rotation, we will weigh again. And what is the loss from the initial weight? So any loss in the tablet weight after rotation will be determined. So we have to wait. So resistant to loss of weight indicates that the tablet withstand abrasion in handling, packaging, coating, and the shipment. So next is a disintegration time. So this is very important to have an idea of the dissolution, because the tablet need to break up or disintegrate first, and we go for the dissolution process. So disintegration time will measure the time required under a given set of the condition for a group of tablet to disintegrate into particles. So, and it will promote greater surface area and availability of the drug. Okay, basically we will put the six tablet in the 6 vessel, and we'll immerse in the purified water and see how the disintegration, how disintegration occur, and we'll record the time. So next is a coating. So coating is very important to protect the tablet. So actually coating is achieved by covering the core tablet or uncoated. So before coating, we call the compressed tablet as the core tablet or uncoated tablet, okay, with the coating solution. So purpose we need to put the tablet is to protect the drug from the moisture, air, and for stability reason. Next, to mask the unpleasant taste or odor for some drug substance. For example, for the health supplement, vitamin, and to improve the product identity and appearance, and also to have the modified release or control release of the drug substance from the tablet, such as for the modified release, we use the enteric coating. So there are various types of the tablet coating. For example, the sugar coating, film coating, organic coating, enteric coating, and aqueous film coating. But generally here we use film coating and also the enteric coating. Okay, is there any question from your side?
Hello, Miss.
Hello, yeah.
There is one question from Muhammad Kardawi. Is there minimum number of tests required during IPQC process for tablet?
Oh, for minimum.
Minimum number of tests required for IPQC.
For IPQC generally is during the tablet compression. So for this IPQC, it depends on us. For during tablet compression, we need macam kita kena identify the tablet weight during the compression. Kita kena ada the consistent tablet weight, and also see the appearance, the hardness. So this is a minimum lah, minimum. So 1, 2, 3, 4.
Okay, thank you.
But yeah, disintegration time.
There's another question from Mayamin. What is the major problem in producing highly potent drugs? Highly potent drug.
High important drug. Okay, for high potent, right?
High potent.
Wait,
Okay, sure.
so for high potent drug, actually we have to challenge dia masa nak tengok dia punya content uniformity dia. Because kalau content uniformity is very important, nak tahu dia punya uniform tak, dia punya the dosage dia. Sebab kita nak dapatkan the therapeutic effect yang kita nakkan. So major problem dia like in term of the content uniformity of the tablet.
Okay, thank you, Miss. We have another question from Nur Shahida Shahira. As we all know, particle size reduction is important to reduce coarser size particle to small masses with higher surface area. However, if the particle is too small, the forces will dominate it and tend to clump together back to coarser size particle. So she wants to know if for tablet, at which particular size particle is suitable throughout the entire process? And how do you handle this clumping problem throughout the process?
Or if the particular size reduction. So usually for the particle size reduction, before we go for the blending, we have to sieve the particle according to the mesh number, the mesh or sieve number that we use. For example, mesh 30, usually we go for the mesh 30 for the after the blend. Before the blending we have to sieve, right? So usually we use the mesh number 30 for our practice, then go for the blending. And that's the particle size. We follow the mesh number of the mesh number, the sieve that we use. For clumping, if too small particle, usually lah our practice and my experience tengok kalau if the fine particles, the tablet susah nak form, so because it's very fine particles. So we need to go to the if the direct compression method is not suitable, so we have to use the the granulation to form the fine powder to form the granules to form a proper compressed tablet.
Okay, thank you, Miss. Another question from Farhan Masda. During product dossier development, I noticed we need to include CFS, CPP, and COA. Where do I get these documents and what's the difference between CFS and CPP?
Sorry, may I know the CFS mean?
CFS and CPP.
Can I Farhan to explain CFS? Sorry.
CFS, Certificate of Free Sale.
Okay, CPP.
Certificate of Pharmaceutical Product.
Oh, okay. A certificate of analysis. Okay, basically, all the certificate required for the API, we will request from the manufacturer. So basically, usually lah selalunya kita akan minta the certificate of analysis of the API, and also the drug master file. Drug master file is very important during the product registration. So we request from the manufacturer or the supplier.
Okay, thank you, Miss. I think I have one last question from my Sarah Abdulatif. Can you share your experiences on the process of selecting type of excipients that you want to include in formulating generic medicines? And how do you decide the manufacturing process?
Okay. Sorry, can you repeat the question?
Okay. Can you share experiences on the process of selecting types of excipients that you want to include in the formulation? And how do you decide the manufacturing process?
Okay. For selecting of excipient, so basically, kita orang akan tengok the reference product, what the excipient usually they will use. There are list of the ingredient. Usually, dia orang akan bagi tahu. So from there, we try to follow. We follow the excipient they use according to the grade. According to the grade lah, for the direct compress, okay, for the for example lah, if product to moisture sensitive, so we have to use the lactose which lactose anhydrous, not lactose monohydrate lah, because it's a moisture sensitive. So for example, it's a selecting type of excipient use. So basically, so we have the list of ingredient. So from there, we can get the idea what process they will use. So that's why kita nak tahu proses apa semua, we have to have do a thorough literature review. So usually innovator product, they got the patent. So you can find through the FDA patent. So from the patent, usually they will explain the process they involve to formulate the product. So we will get an idea to develop the product. So basically, kalau kat sini, our practice, first we go for the direct compression is okay or not. This is the first approach. If the direct compression is not feasible, due some ada tak boleh nak dapat dia punya, ada problem dengan container uniformity ke, cannot compress ke, kan, the problem during the compression. So we try to use the wet granulation. Lepas tu kat sini dry granulation, we just have one roller compactor. We never go for slugging. For roller compactor, we have a granulation using roller compactor. So basically, you see the ingredients, tengok dia punya proses dia. Dia sama dia wet granulation ke macam mana. So, kalau nampak wet granulation, selalunya dia akan guna binder, something like we can get the information of the manufacturing process from the pattern. Also the process, the properties of API, boleh tak dia go for wet granulation? We cannot go, so we first approach is the direct compress. It's not feasible, go for wet granulation. Macam tu our practice.
Okay, thank you, Miss.
Tapi session sebenarnya 2 jam kan, tapi saya dapat 1 jam dia. So, yeah, any other question? Mm-mm. 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 Ah, masuk awak during compression ke? During the process? So macam mana kita handle lah? So contohlah, so kita orang proses kan selalunya problem kita orang kat compression. Okay. Contohlah, saya pernah buat satu tablet ni moisture sensitive. Bila moisture sensitive, dia punya tablet akan capping tu macam dia punya tu apa nama tu, atas dengan bawah dia ni kan terpisah kan, capping. So semua kita dah control, for dispensing semua kita dah control, sampai formulation sampai compression jadi problem dia sticking, ataupun kita panggil capping. Sticking tu maknanya dia powder tu melekat dekat face of the punches, upper ke lower punches. Kalau macam tu, kita orang selalunya akan improve the process, ataupun kita akan control the humidity dulu. Itu yang saya punya experience lah, control humidity. Kalau tak boleh juga, kita kena modify contohnya the formula lah. Contoh mungkin gliding dia tak cukup, so kita increasekan gliding. Itu cara kita orang, salah satu experience saya yang saya buat lah. Lubricant dia ke, itu kita orang go through dulu dia punya proses, dia punya proses lah. So experience saya. Any other question? Jawab soalan awak ke Amirul? So the next question is, how long is the overall formulation process for tablet for one batch? So basically you means the process of making the tablet, right? Amirul Arifin? Okay. Selalunya, first kita orang sebelum masuk lab, kita orang kena ada dispensing sheet. The excipient use, dah tahu dah ada punya percentage, dia punya amount, batch size apa yang kita nak guna, nak buat semua. Lepas tu, we go for dispensing. Selalunya 1 hari dah boleh siap lah. From this dispensing, if direct compress memang senang lah. 1 hari macam tu boleh, ataupun half day macam tu kita boleh buat. Kalau wet granulation, we need to wet granulation and drying, dan drying selalunya ambil masa. So usually 1 day lah saya boleh cakap. Yeah. The overall formulation. So usually from dispensing into up to the compression. So maybe next day we will do, kalau dia punya tablet, kita dah evaluate the characteristic of the tablet in terms of dia punya disintegration, the hardness ni mau okay. So we go for, first lepas kita orang dapat uncoated tablet tu selalunya, we'll go for the dissolution. We will test for dissolution. If everything macam okay, so we'll go for packaging, and then we'll set down for the R&D stability study. So basically for process of the tablet take about one day. Okay, Amirul? Okay. The next, the process mixing, coordination, compression, and the test that you have mentioned in the is done for the pilot batch, right? Ya betul. Pilot batch. Maksud you apa ya, Siti Nur Syaira Zakaria? Dan pilot batch. Maksudnya saya buat macam tu ke masa awak? Oh, selalu kalau pilot batch, memang semua ni memang kena, ada orang kena record. Okay, selalu macam ni. Kalau pilot batch manufacturing, formulator, kita orang datang sana, kita witness the process. Dapat nanti, the production team will collaborate with the production and the technician. So, whole process, technician yang akan buat, the operator will do. So, we have to witness. Lepas tu, anything macam diorang akan tanya kita, betul ke you dapat ni? Masa you punya R&D. So, macam mana? Dapat tak end point of the granulation? Macam tu lebih kurang. So the hardness, variability semua tu diorang akan buat. QC punya operator or technician yang akan buat yang hardness factor, hardness semua tu, variability. Tapi kalau kita orang R&D yang kita orang kena buat lah. Hardness, variability semua. Sebab kita orang dalam lab, walaupun testing of the product sebenarnya analytical kan, analyst, but during tablet compression kita nak dapat consistent formation of the tablet tu memang kita orang buat. Test the hardness, tablet weight. This is very important to control during the compression. Any other question? Siti Nur Syaira, okay? Any other question?
Miss, I think that's all from us. Okay, thank you for the interesting presentation and the Q&A session.
Okay. For case study, how is it? Macam korang buat macam mana ya?
Sekejap. Kak nak ni terus ke? Present terus ke study, boleh bincang terus kalau student ada?
Boleh je. So,
boleh.
dah habis presentation. So, I need to have a macam ni lah. Dengan korang lagi best lagi kot. Ya. Boleh juga case study.
Yang the latest one lah kan?
Latest yang awak bagi saya
Apa dia?
Latest yang Abi bagi tu
Sekejap. Saya pun. Kak nak ada ke? Kalau tak terus present je sebab saya buka daripada phone.
Oh, okay. Sekejap ni. Mana? Kalau daripada phone boleh share ke? Tak.
Boleh download dulu tak daripada apa ni? WhatsApp kan?
WhatsApp, yep. Sekejap ya. Okay, yang ni kan. So we will proceed with the case study. Everyone is here?
Yes.
Okay. Boleh? Okay, for this one, ada dua case study here. So kat sini briefly saya akan bagi tahu apa yang korang kena dapatkan info untuk jawab soalan-soalan ni. Boleh kan? Okay. As for first case study, so marketing department has requested R&D team to develop a new generic product of drug combination of valsartan, hydrochlorothiazide tablet 160 mg, 25 mg. So literature review and the characterization of RLD are part of the step need to be performed prior to the product development. So perform both steps with adequate information and explanation by referring to the innovative product of the same strength, drug and strength mentioned above. So basically, for this question,
So ada soalan apa-apa tak pasal question ni? Faham tak?
korang buat di dalam group in group for to answer the case study. So basically for this question, so kena buat product which are valsartan and hydrochlorothiazide tablet 160 mg and 25 mg. So in order to have information about the product, so you can refer to the package insert or the packaging box of the product, and also you can usually the online you can get the information, but for the hardness, for example parameter, if you want to determine the hardness, the disintegration time, dissolution, of course you cannot because you need to perform the physical testing to get the information. So basically this one you can identify or get the information from online lah. So any question regarding this one, this case study? Oh, saya nak point je untuk jawapan A tu. Nah, point je. For the step and perform both step. And for the literature review, you can get 3 points, 2 points macam tu. 2 to 3 points. 3 points lah. So for the characterization of the RLD tu, you can 3 lah, 2 to 3 points lah for that.
The minimum required for yang kena ada dalam review lah kan?
Ya. As I present tadi lah. You can refer.
Okay, so you kena tahulah apa ni valsartan hydrochlorothiazide 160 25 tu apa dia punya innovator drug semua. Kena carilah.
This is generic. It's give a generic. Selalunya kita akan dapat generic in term of dia punya API name, right? So you have to find what is the innovator lah. So you can refer from that. Okay, next, what the step to be done before developing? So other step. So I have mentioned it before. You can get the information and see what are the parameters need to be determined. Parameters means regarding the innovator, like I mentioned before, what the information you should have. The idea you can get from the slide. So the information you have to search for it with the answer, parameter, and also the answer. What the parameter and also what the answer. And also you identify the excipient used innovator. So you need to know the innovator first. Then after the innovator, you have to find the excipient. What are the excipient used for the product, for the dosage form, for the strength, and so you have to state the function for each excipient. The function tak payah nak macam-macam cakap pasal as a diluent ke, disintegrant ke, macam tu je. So any question regarding case 1?
No, Miss.
Okay. For case 2, we proceed with case 2, study 2. So this one, R&D team need to develop a generic drug of antihypertensive drug, which is a film-coated tablet. However, it is found that the active pharmaceutical ingredient of the tablet is sensitive towards the moisture, so suggest one suitable manufacturing process, and also give a the justification on the suggestion. So basically, this one I need what the process involved during the manufacturing process, what anti-what. Then you state the advantage of the suggested process that you suggest, to advantages and to disadvantages of the process. The simple sebenarnya. You can, yeah.
Miss,
Yes.
so we have 2 case study only, isn't it?
Yes.
Okay.
So any other question you want to ask? How many of you actually for one batch? Finally, right?
There are actually 180 plus, but some of us sharing our laptop.
Oh, ramai. Yeah.
I think there is no more question from the students. Finally, we have come to the end of the presentation. We would like to say thank you to the presenter for the interesting presentation and also to the students for active participation. Hopefully, the presentation will be beneficial for everyone. Thank you for your attention and Assalamualaikum warahmatullahi wabarakatuh.
Thank you so much.
Thank you, Miss.
Thank you.
Thank you, Miss.
Thank you.